All right, so we're on to page 2. As you can see, I have a lot of examples here. I really wanted to show you the wide variety of things that could go down when you're working with use substitution. So with the first one, it's hard to know what the BLOP is because there's actually, this is like a triple chain. There's the square function, the secant function, and then the guts inside. So this is where you want to think back to the different functions that we have antiderivatives for. And secant squared is one of them. The antiderivative of secant squared x is tan x. So for this function, since I know the antiderivative of secant squared whatever, this is the part that I need to turn into one variable, the stuff inside the secant squared. So the u is x plus 2. And then the du, that's actually easy for this one because it's just 1 dx. So dx and du equal each other. So that's step 1. Step 2, I'm going to substitute that in here. So that's just going to become secant squared u and then du. And then we have an antiderivative for secant squared u. It's tan u plus a constant. Oh, I just did part 2 and 3 in one. Okay, and then step 4, I just re-substitute back. So this would be tan of x plus 2 and then plus a constant. So notice when the derivative of the guts is 1, you don't even really need to do use substitution. And these are the kinds of problems that they gave you, they threw at you in 6.1 and I think 5.5 too, or 5.4, I don't remember which one. Because if the derivative of the inside is 1, notice how basically I'm just doing the antiderivative of secant squared. It's just tan of the same thing. So feel free to just skip all the steps if you can. Like if you can see it, you can go straight from here to here. It's up to you. But if not, following the same 4 steps will work. Okay, number 4, I just threw it on here because it looks weird, but it's actually really easy. So let's just start by rewriting, because I think it's just the way it's written is like scary. But first I'm going to start by putting the dx on the side because I think that helps people like breathe a little bit. And then I'm gonna turn this into just a function because it's 1 over sine squared. That's really just the same thing as cosecant squared. There's no need for all this 1 over sine squared business. Okay, much less threatening, much less scary. So sometimes it's just a matter of rewriting the problem, and then it's like, I can do that. All right, let's start with the steps. So I think it's now obvious, now that we kind of reconfigured everything, that really I just want to let u be the 3x part, because this is the same idea as this one. I know the antiderivative of cosecant squared of x, or of something. I don't know it of 3x. So basically I just let u be 3x, and then du would be 3 and then dx. Okay, and then if I want to solve for dx, I divide by 3. So dx becomes du over 3. And then I can start substituting. So for step 2, I'm going to substitute in my nicer looking one. So I'm going to get integral of cosecant squared u and then du over 3. And then you know me, I like pulling out the constant. I don't like dealing with it inside the function. It stresses me out. Okay, so now I'm just basically taking the antiderivative of cosecant squared, which, like secant squared, which got me tan, is going to get me cotan, but it's just going to be negative. So this is basically going to be negative 1/3 cotan u plus a constant, and then step 4, I put the x stuff back where u is. So I get negative 1/3 cotan of 3x plus a constant. And if at any time you're unsure of your answer, find the derivative of this, check to see that it equals that. If it does, you're good to go. Okay, 5, looking scary. Turns out to be crazy easy. It's almost scary how easy it is, given how scary it looks. Okay, first of all, notice this is d theta, so our variable here is theta. So treat theta like we've been treating x in all the other problems. And this might look scary because it's like, oh no, we have a product of functions. We don't have a product rule for integrals. I mean, there is one, but you haven't learned it yet. Well, that's okay because this product has an antiderivative. if this had just been x, like secant x tan x, the antiderivative of that is just secant. So the problem really is the fact that it's something other than x in there. So we're going to let u be that something. We're going to let u be the blob, which is theta plus pi over 2. Now remember, this is in terms of theta. So du would just be 1 d theta, because that's just, it's like 1 times theta. So it's just 1 d theta. So that's step 1. So step 2, we're going to go ahead and substitute. So I get secant u tan u, and then du, because d theta and du are equal to each other. Step 3, I just take the antiderivative of that, which is, like we talked about, secant u and plus a constant. And then in step 4, I plug the theta stuff back in for u. So this ends up being secant theta plus pi over 2, and then plus a constant. And again, if you're not sure, find the derivative of this and see if it equals that. Okay, 6. Whew, look at this one. This is a doozy. A doozy. Okay, now this is where it's unclear. Like, what do I make u? I have no idea. This is where you look for the presence of a function and its derivative. A function and its derivative. Now, the reason I can see that this is going to be the derivative of that is because this is r cubed and this is r squared. Because of that, I'm going to let the one with r cubed be u, so that when I find du, it's going to have an r squared in it that will cancel with this r squared. So that's why I'm going to let u equal 1 minus r cubed, because du is going to be negative 3r squared dr, and that is going to make dr equal to du divided by, this is the key right here, negative 3r squared. This division of negative 3r squared is going to cancel out that r squared. And so you'll see that right now. So we're going to substitute right now. So I've got 9r squared times dr, which is this, times du divided by negative 3r squared. All that divided by the square root of u. Now remember, I can't integrate until all the r's are gone and only u's and du's remain, and there can be constants in there too, constant multiples, which is exactly what's going to happen, because these r squareds are going to cancel, which is perfect, which is why I chose r cubed to be u instead of r squared. And then the 9 divided by negative 3 will become negative 3. So then I end up with negative 3 du divided by the square root of u. Okay, so the third step is integrate, which you know me, I like pulling the constant out. And then I don't like dealing with radicals, so I'm going to change that to u to the negative 1/2 du. And so that's going to be negative 3 times u to the 1/2 divided by 1/2 using the power rule there. And so that basically becomes, oh, and dividing by 1/2 is the same thing as multiplying by 2. So that basically becomes negative 6. So this is equal to negative 6 u to the 1/2 plus a constant. And then step 4, I plug this function with the r's back in here for u. So it's negative 6 times 1 minus r to the third, all that to the 1/2 plus c. And yeah, so there is our answer for 6. Okay, and then 7 is similar to 6 in that it's kind of hard to tell what which function to call u. Sorry, which function to call u. So you look for the presence of a function and its derivative. Now between cotan and cosecant, you have to decide which one's the function, which one's the derivative. Well, I know that the derivative of cotan is negative cosecant. So this one's the function, that one's the derivative. So I'm going to let u be the function. So u is going to be cotan x. And then watch, when I go to find du, I'm going to end up with negative cosecant squared x and then dx, which is great because when I go to solve for dx, I have to divide by a negative cosecant squared, which will allow me to cancel this out eventually when I substitute. So dx is going to be du divided by negative cosecant squared. Okay, so step 2 is to substitute. So I end up with the square root of u times cosecant squared x times du divided by negative cosecant squared x. Cosecant squared x is cancel as predicted. I do have that negative 1 there that I can't forget. And so I have negative integral of negative rad u du. Okay, time to integrate. So I'm going to pull the constant out. I don't like constants inside. I'm going to pull them out. And I'm going to call this u to the 1/2 du. And so that ends up being negative u to the, let's see, if I add 1 to that, I get 3/2. And then divided by 3/2. And I ran out of room. No. So I'm going to go to the back. So then, okay, so dividing by 3/2 is the same as multiplying by 2/3. Here, I can squeeze that part here. So we'll do negative 2/3 u to the 3/2. And then plus a constant. Okay, so then the last step, which is substituting back, will be on the back. So last but not least, for step 4, we're going to plug the cotan. I think that's what it was. Yeah, the cotan back in for u. So I'm going to end up with negative 2/3 times cotan x to the 3/2 power and then plus a constant. Okay, so that's that one. Okay, and then in our last video, we will do page 3.